Welcome to SWAM's online lecture series on the topic Database Management System. My name is Muhammad Ubedullah Bukhari, working as a professor in the Department of Computer Science, Aligarh Muslim University, Aligarh. I am pleased to have you join me today. In this lecture, we will discuss few interesting topics including normalization for relational. Let's begin the journey of today's lecture. In the last lecture, we have discussed advanced relational calculus. Before proceeding with today's agenda, I would like to discuss some questions that I had given you in the last class. The first question was, explain relational calculus and its type in detail. The answer is, relational calculus is a formal method used in database management system to specify queries for retrieving data from relational databases. It focuses on what data to retrieve rather than how to retrieve it, making it a declarative approach to querying. There are two main types of relational calculus: tuple relational calculus and domain relational calculus. TRC specifies queries by describing the desired tuple to be retrieved, while DRC specifies queries by describing the desired domain for result. Both types provide the theoretical foundation for query languages like structured query language and enable precise and expressive query capabilities in relational databases. The second question was, what are the key features of relational calculus and explain in detail? The answer is, relational calculus, a formal method in database management systems, boasts a key feature facilitating precise queries. First is declarative nature. Users specify what data to retrieve rather than how to retrieve it, allowing for intuitive query formulation. Theoretical foundation. Rooted in mathematical logic, it provides a theoretical foundation. Rooted in mathematical logic, it provides a solid theoretical basis for query languages. Expressiveness. Enable complex queries through precise specification of desired tuple or domains. Compatibility forms the basis for query languages like structured query language, facilitating seamless integration with the existing database system. Abstraction abstracts implementation details, allowing users to focus on querying the database without concerning themselves with retrieval mechanism. Overall, relational calculus empower users with a powerful declarative query approach, enhancing the flexibility and efficiency of database interactions. So let us begin the agenda of the today's lecture, which is to discuss the following topics you can see on the screen: normalization for relational databases and all the normalization forms along with example. So we'll begin with the very first topic of the today lecture, normalization for relational database. Normalization is basically a process for minimizing redundancy from a relation or set of relations. Redundancy in relation may cause insertion, deletion, and update anomalies. So it helps to minimize the redundancy in relations. Normal forms are used to eliminate or reduce redundancy in the database tables. Normalization is a crucial process in database management system aimed at optimizing the structure of relational databases to enhance data integrity and minimize redundancy. It involves organizing tables and their attributes in a systematic manner to ensure effective data storage and retrieval. The process follows a series of normal forms, each addressing specific issues related to data redundancy and dependency. In the database management system, normal forms are a series of guidelines that help to ensure that the design of database is efficient, organized, and free from data anomalies. There are several levels of normalization, each with its own set of guidelines known as normal forms. Now let's discuss the types of normalization. There are several types of normalization, each addressing specific issues related to data redundancy and dependency. The most common types of normalization are first normal form, we can say 1NF, second normal form 2NF, third normal form 3NF, Basi code normal form BCNF, fourth normal form 4NF, and the last fifth normal form 5NF. Let us discuss each normal form in detail. First normal form. First normal form is the initial stage of data normalization in database management system aimed at organizing tabular data to eliminate redundancy and ensure data integrity. In first NF, each table in the database must meet the following criteria. Atomic value. Each attributes or column within the table must contain atomic value, meaning that each value in the column should be indivisible. This ensures that there are no multi-valued or composite attributes. Unique column names. Every column in the table must have a unique name. This prevents ambiguity and confusion when referring attributes in queries. Order rows. The rows in the table must be ordered, meaning that there is a specific sequence or order in which the rows are stored. This allows for consistent and predictable retrieval of data. By adhering to these criteria, first normal form ensure that the data is organized in a structured or consistent manner, facilitating efficient storage, retrieval, and manipulation of information. Achieving first normal form is typically the first step in the normalization process, laying the foundation of higher normal forms such as second normal form and third normal form. Second normal form. Second normal form is the second stage of database normalization in database management system. Following first normal form, its primary goal is to further eliminate redundancy and dependency issues in the relational database. In 2NF, a table must meet the following criteria. Be in first NF. Before a table can achieve 2NF, it must first satisfy the requirement of the first normal form, including having atomic value and unique column names. Removal partial dependencies. In second normal form, every non-prime attributes, that is attributes that are not part of the primary key, must be fully functionally dependent on the entire primary key. This means that each non-prime attributes must depend on the entire primary key, not just a part of it. If any non-prime attributes is dependent on only a portion of the primary key, it indicates a partial dependency and violate 2NF. To address partial dependencies and achieve 2NF, the table may need to be decomposed into multiple tables, with each table representing a separate entity or relationships. This decomposition ensures that each table contains only attributes that are fully functionally dependent on the primary key, thereby reducing redundancy and improving data integrity. Thereby reducing redundancy and improving data integrity. Overall, achieving second normal form helps ensure that data is organized efficiently and accurately, laying the groundwork for higher level of normalization and enhancing the overall quality and performance of the database. Next is third normal form. 3NF is a stage of database normalization in database management system. Following first normal form and second normal form, it aims to further reduce redundancy and dependency in the relational database. In third normal form, a table must meet the following criteria. Be in 2NF. Before a table can achieve 3NF, it must first satisfy the requirement of second normal forms, including being a first and having removed partial dependencies. Remove transitive dependencies. In third order form, every non-prime attributes, that is attributes that are not the part of primary key, must be non-transitively dependent on the primary key. This means that non-primary key attribute should not depend on other non-primary attributes within the same table. To achieve the 3NF, tables may need further decomposition to remove transitivity dependencies. This process involves splitting the table into multiple tables, with each table corresponding a distinct entity or relationship. By ensuring that each attribute depends only on the primary key and not on the other non-key attributes, 3NF helps eliminate redundancy and improve the data integrity. Overall, achieving third normal form enhances the overall quality and performance of the database by organizing data more efficiently and accurately. It establishes a more robust data model that minimizes redundancy and ensures consistency, laying the groundwork for more advanced normalization techniques and optimization database design. Bowsi code normal form. BCNF is advanced stage of normalization in database management system that builds upon the principle of third normal form. It aims to eliminate the certain types of anomalies by further reducing redundancies and dependency in a relational database. In BCNF, a table must meet the following criteria. Be in 3NF. Before a table can achieve BCNF, it must first satisfy the requirement of third normal form, including being first and second normal form and having removed transitive dependencies. Functional dependencies on candidate key. In BCNF, every non-trivial functional dependencies where the dependent attributes is not a subset of the primary key must be a dependency on the candidate key. This means that every determined attribute determining another attribute's value must be a candidate key. BSNF aims to address certain anomalies that can occur in 3NF, particularly those related to non-trivial functional dependencies. By ensuring that every dependency is based on the candidate key, BCNF eliminates the possibility of certain update anomalies, insertion anomalies, and deletion anomalies. BCNF may require further decomposition of a table to remove dependencies. that violate the BCNF criteria. This decomposition involves splitting the table into multiple tables, each representing a distinct entity or relationship, and ensuring that each table adheres to the BCNF requirement. Overall, achieving BIC code normal form enhances data integrity and consistency in the database by minimizing redundancy and dependency. It provides a more robust data model that reduces the risk of anomalies and facilitates efficient data storage, retrieval, and manipulation. Fourth normal form. Fourth normal form is a level of normalization in database management systems that addresses multi-value dependencies within a relational database. It builds upon the principle of third normal form and aims to further reduce redundancy and improve the data integrity. In fourth normal form, a table must meet the following criteria: be in 3NF. Before a table can achieve 4NF, it must be satisfied the requirement of third normal form, including being first and second normal form and having removed transitive dependencies. Eliminate multi-value dependencies. In fourth normal form, every non-trivial multi-value dependency must be dependency on a candidate key. This means that if a table has multiple candidate keys, it should not have any non-trivial multi-value dependencies between attributes. Multi-value dependencies occur when the presence of one or more rows in the table implies the existence with multiple values. 4NF aims to eliminate such dependencies to avoid certain anomalies that can arise during data manipulation. Achieving fourth normal form may require further decomposition of a table to remove multi-value dependencies. This decomposition involves splitting the table into multiple tables, each representing a distinct entity or relationship, and ensuring that each table adheres to the 4NF requirements. Overall, the last is fifth normal form. Fifth normal form, also known as Project Joint Normal Form (PGNF), is an advanced level of normalization in database management system that addresses joint dependencies within a relational database. It extends the principle of fourth normal form and aims to further reduce redundancy and improve the data integrity. In fifth NF, a table must meet the following criteria: be in 4NF. Before the table can achieve fifth NF, it must first satisfy the requirement of the fourth normal form, including being first, second, and third normal form and having removed multi-value dependencies. Joint dependencies occur when the value of a certain attributes in one table are dependent on the value of attributes in another table. Fifth NF aims to eliminate such dependencies by composing. Fifth NF aims to eliminate such dependencies by decomposing table into a smaller, more granular tables, each representing a distinct entities or relationships. This decomposition ensures that each table contains only attributes that are strictly related to the primary key and does not rely on the other tables for information. Overall, achieving the fifth normal form enhances data integrity and consistency in the database by minimizing redundancy and dependency related to join operations. It provides a more robust data model that reduces the risk of anomalies and facilitates efficient data storage, retrieval, and manipulation. Now, after the discussion of all forms, we will going to see the advantages of normalization. Normal form in database management system offers several advantages that contribute to the efficiency, integrity, and maintainability of database. Reduce data redundancy. Normalization helps to eliminate duplicate data in tables, reducing the amount of storage space needed and improving database efficiency. Improve data inconsistency. Improve data consistency. Normalization ensures that data is stored in a consistent and organized manner, reducing the risk of data inconsistencies and error. Simplified database design. Normalization provides a guideline for organizing tables and data relationship, making it easier to design and maintain a database. Improved query performance. Normalized tables are typically easier to search and retrieve from data from and resulting in faster query performance. Next is easier database maintenance. Normalization reduces the complexity of database by breaking it down into a smaller, more manageable tables, making it easier to add, modify, and delete data. Data integrity. Normalization reduces data redundancy and ensure that each piece of information is stored in only one place. This minimizes the risk of inconsistencies and update anomalies such as insertion, deletion, and modification anomalies, which can occur only redundant data is present. Flexibility and scalability. Normalization allows databases to evolve and scale more easily over a time. And new requirements emerge or the volume of data increases. Normalized databases can be adopted and expanded without sacrificing data integrity or performance. The last is support for complex data models. Normalization provides a solid foundation for complex data model and relationships by breaking down data into smaller, more manageable units. Normalization enables the creation of sophisticated data structures that accurately represent real world entities and relationships. Overall, normalization plays a crucial role in designing efficient, robust, and maintainable databases, contributing to the overall effectiveness and reliability of data system. Disadvantage of normalization. Disadvantage of normal form. While normalization offers numerous advantages in database management systems, it also comes with a certain drawbacks to need to be considered. First is increased complexity. Normalization can lead to increased complexity in database design, breaking into tables into smaller units and managing relationship between them may require more efforts and expertise. This complexity can make the database schema harder to understand and maintain, especially for less experienced developer. The next is query performance overhead. Highly normalized database may incur performance overhead due to the need of frequent join across multiple tables to retrieve related data. While normalization reduces data redundancy, it can also increase the number of joins required for complex queries, leading to slower query execution times, particularly in a large databases. Storage overhead. Next is potential for data inconsistency. And the last is complexity for updates and insert. Maintaining data integrity in normalized databases can be more challenging, and particularly when performing updates or inserts that involve multiple tables, ensuring that changes are propagated correctly across related tables require careful attention to detail and may involve complex transaction and error handling logic. Denormalization overheads. In some cases, denormalization may be necessary to improve query performance or simply data access patterns. However, denormalization introduces its own set of challenges such as increased data redundancy and the potential for data anomalies, which can offset the benefits of normalization. Overall, while normalization is essential for promoting data integrity and consistency, it's crucial to strike a balance between normalization and performance, considering the specific requirements and constraints of the database environment. In some cases, a judicious combination of normalized and denormalized structure may be necessary to achieve the desired balance between the data integrity, performance, and manageability. Now, after learning the concept of normalization forms, let me explain the all normal form with the help of examples. In first normal form requires each column in a table contains atomic values, meaning no repeating groups or array are allowed. Let's start with first normal form, which requires that each column in a table contains atomic values. In our example, we have a table storing information about students and course they are enrolled in. However, the course column violates first normal form because it contains multiple values separated by commas. To bring it into first normal form, we will split the courses column into multiple rows, each representing a single course for each student. As you can see on the screen, there are two tables. The first one is the original table and the normalized table. As you can see, by splitting the course column, we have ensured that each cell contains only single value, satisfying the requirement of first normal form. Second normal form. Second normal form requires that the table in first NF and all the non-key attributes are fully functionally dependent on the entire primary key. Expanding on the previous example, suppose we now include the instructor for each courses in the first normal form table. The instructor depends on the course, not the entire primary key, student ID or course. Moving to second normal form, this form built upon first normal form by ensuring that all non key attributes are fully functionally dependent on the entire primary key. Let's expand our example to include the instructor for each course. In our original table, the instructor column depends only on the course, not the entire primary key, student ID and course. To bring it into second order form, we will split the table into two separate tables, one for student course information and another the course instructor information. 3NF requires that the tables in 2NF and there are no transitive dependencies, none key attributes depends only on the primary key. Suppose we add information about the instructor office location. The office location depends only the instructor, not the course or student. Finally, let's discuss third order form, which eliminates transitive dependencies. In our previous example, suppose we add the instructor's office location. However, the office location depends only on the instructor, not on the course or student. To bring it into third order form, we will split the table further to ensure that each non-key attributes depends only on the primary key. As you can see on the screen, there are two tables. The first one is the original table and the normalized table. By separating the tables, we have eliminated transitive dependencies and ensure that each non-key attribute depends only on the primary key, satisfying the requirements of 3NF. BCNF is an advanced form of normalization that deals with certain types of functional dependencies. It requires that every determinant is a candidate key. Let us consider a table representing employees information where the employee ID determines the department and the department determines the department head. In this example, the determine that in this example, the determinant department is not a candidate key because it does not uniquely determine all attributes. To bring it into BCNF, we split the table into two, one for employee information, another for department information. To bring the table to BCNF, we split it into two separate tables, one for employee information and other for department information. The employee table contains employee ID, employee name, and the department, while the department table contains the department and department head. Each table certifies BCNF as the determinant employee ID in the employee table and the department in the department table is a candidate key. Four-normal form deals with the multi-value dependencies, ensuring that no non-trivial multi-value dependencies exist within the table. Let us consider a table representing a bookstore where each book can have multiple authors. In this example, the multi-valued dependencies exist between book title and authors. To bring it into 4NF, we split the table into two, one for book and another for author. The book table contains book ID and book title, while the author table contains the author ID and author name. We introduce a junction table to establish the many-to-many relationships between book and authors, ensuring that each table satisfies 4NF. Fifth normal form deals with the joint dependencies and ensure that every non-trivial joint dependencies is implied by the candidate key. Let us consider a table representing a university where each course may be. In this example, there is a joint dependency between the course name and prerequisites. To bring it into fifth normal form, we split the table into three, one for course, one for prerequisites, and one for relationship between them. The course table contains course ID and the course name, and the prerequisite table contains prerequisite ID and prerequisite name, and the course prerequisite. The relationship between course and prerequisites. Each table certify fifth NF ensure that no non-trivial joint dependency exists. In today's lecture, we discuss about the normalization for relational databases. Now let us access your knowledge and check your progress with some important questions from today's lecture. Your answer will enhance your concepts as well as make you as well as make you more aware about the topic. The today's question to test your knowledge are: first question is explain the different normal form in normalization. Next, what are the primary goals of normalization? Describe the steps involved in normalizing a table to comply with first normal form, second normal form, and third normal form. What is basic code normal form and why it is important in database normalization? In our exploration today, we have navigated the intricate world of data modeling using the normalization for relational databases. In today's lecture, we have discussed normalization form with the help of so many examples. I hope you enjoyed this lecture. Hope to see you soon in the next lecture. Till then, keep studying. Thank you.